So in this video, we're going to look at angles. And so this is task 7 in your packet on angles. So we're going to look at the different type of angles. I'm sure you've heard most of these, but just to kind of review them. So first off, an angle is defined as two rays that share a common endpoint. Okay, so this is one ray, and then this is another ray, and then this is considered an angle. And they are measured in degrees or radians. In this class, we will just do degrees. If you took trigonometry at some point, you might have dealt with radians. But the measure of the degrees is kind of this measure here. It measures how wide the angle is. So in this course, we'll use degrees. We use 3 capital letters with the angle symbol in front of the letters to name an angle. You can also use a number inside the angle to name it. So if this is my angle, how I could name it is I could say angle ABC, or I could name it angle CBA. So when we name it with 3 letters, we kind of start on one end of the angle, and then we go to the point where the 2 rays intersect, and then we go to the other part of the angle. Where the 2 rays intersect is called the vertex. Okay, so this point B represents the vertex of this angle. The vertex always has to be in the middle when you're naming the angle. So again, I can start at C or I can start at A and then trace it. I cannot start with B. Now, for this angle, if it's a single angle by itself, you can also name it with just one letter, and that would be the letter of the vertex. So I could also name this angle as angle B. And we always put the angle symbol in front of it to indicate angle. And then occasionally they'll put like a little number inside the angle. And so you could also name it as like angle and then that number. So angle 1. Now, just kind of as a side note, I'll draw something down here. If you have something like this, an angle, and then you have another ray inside of it that splits it into 2 different angles. And again, I have my letters. If you have this, you have to name these angles with 3 letters. You can't just say, in this case, angle B, because I don't know if angle B represents this whole angle, like angle ABD, or if it represents this angle ABC, or that represents the angle CDB. So again, if I was naming these angles, if I wanted to name this angle that I'm going to outline in red, I would use 3 letters for that angle. I'm going to put the angle symbol, and I am either going to start with point A or point C. I cannot start with the vertex of the angle. So I'm going to start with like point A, and then I'm going to trace to the vertex B. So it'd be angle A, B, and then I'm going to go to the other ray of the angle and a point on that ray, which is C. Okay, so that would be the red angle that I made. If I wanted to do this blue angle here, for that angle, I would say the angle. And again, I can't just say B, I have to pick 3 letters. So I could either start with C or D, it doesn't matter. So let's say I start with D. Then I go to the vertex of the angle, which is B. And then I go to a point on the other ray, which is C. Okay, and that's this angle that I outlined in blue. If I wanted the entire initial angle, the entire angle, the blue and the red angle put together, I would say angle, and I'm going to do that one in black. I'm going to either start with D or A because those are the points on the two segments that make up the angle. So let's say I'd start with A this time. And then I would go trace the angle to the vertex, so B. And then I would go on the other ray that I want that makes the angle that I'm looking for, which is D. Okay, and then that would be this whole angle here. Okay, now again, all of these I could write the opposite way. So I could write this angle as CBA. It's the same thing. I'm just starting on this side of the angle instead of this one. Or I could write this one as CBD. Again, you need the angle symbol. And this last one, instead of starting with DBA, I could say instead of starting with ABD, I could say angle DBA. So 3 letters, especially when you have multiple rays in one angle. If it's just like a single angle like this, then you are allowed to name it just with that vertex B. So then we have different kind of angles. So straight angles are lines that measure to 180 degrees. And so it's pretty much a straight line is a straight angle. Again, we would have 3 points on it. And if I were to name this, I would say angle either A, B, C, or I could name it angle CBA. Okay. So again, we're never starting, this is technically the vertex of the angle. We're never starting in the middle. We're starting on one end and then going to the other end. So then we have right angles. Right angles have a measure of 90 degrees. To indicate a right angle, we use like this symbol. Okay, so it kind of makes a square with the sides of the angle. That indicates that it's 90 degrees. Okay. A straight angle, to go back to that 180, this measure, because it's a straight line, measures 180 degrees. And so a right angle is half of that, which is 90 degrees. Again, if I were to name it, I'll just use different letters like K, L, M. I would either start with K and M to name it. So I would say like angle K, L, M, or I could name this one angle M, L, K. Okay, and that's a right angle. And then this is my other example. Okay, so then we have acute angles. So acute angles have a measure, and I believe this is updated in your packet. Have a measure, I'm going to add this. This is already in your packet though, but greater than 0 degrees and less than 90 degrees. Okay, so it has to be bigger than 0 degrees and less than 90 degrees. So an example of acute angle is like 30 degrees, or let me make it actually look like 30. So like 30 degrees or 60 degrees or 45 or 89, any of those would be example of acute angles, okay? And again, if we were naming them, we would have 3 letters on them. Or again, I could name these because they're single angles. Like I could say this is angle A and this is angle B. So obtuse angles have a measure between 90 and 180. Okay, so again, when we're talking about a straight angle, we have a straight line that's 180. An obtuse angle is going to look like it's more than 90, but less than the straight line 180. So again, obtuse angles are like 150, 175, 91, 179. Those are all obtuse angles. So those are the three types, obtuse, right, and acute. You can never be both acute or obtuse. If you're acute, you have to be between 0 and 90. If you're obtuse, between 90 to 180. It's impossible to be both of those measures at the same time. So that's a never relationship. Same with between acute can never be right, and obtuse can never be right. But then we have angle pairs. So angle pairs, there's three types: complementary, supplementary, and vertical. So complementary angles are two angles that have a common vertex and whose angles measure sum to 90 degrees. So we would have a right angle, and then we would have two angles, and we could say like this is 30 degrees and this is 60 degrees. And those would be examples of complementary angles. And so if I was saying this, if I was naming them, I would say like angle ABC, which is this top angle, and angle CBD are complementary. Okay, and again, in this case, I have to do 3 letters for each angle because I can't say angle B because it could refer to the 60-degree angle, the 30, or the 90. Okay, supplementary angles are two angles that share a common vertex and whose angles sum to 180. So we have two angles that are going to make a straight angle. So let's say we could say 150 degrees and 30 degrees. That would be an example of supplementary angles. So in this one, we would say angle A, B, C, and angle C, B, D are supplementary. So again, for these, because they're angle pairs, it's a relationship between two angles. So we have to be naming two angles when we're talking about something being complementary or supplementary. So then we have vertical angles. Vertical angles are not always one above the other, but are sort of opposite one another, which is their other name. So I think that definition is really confusing. It's the one given in the packet, but another definition are angles formed by two intersecting lines, and they're the angles that are across from one another. So I would have two intersecting lines. And I'm going to put points on them so I can name these. Okay. So the vertical angles, there's two pairs here. The one pair of vertical angles would be like NOP. I'm just going to put like a mark for this. NOP, this angle here, and QOR, this angle here. So angle, again, when I do that, I'm going to trace the three letters starting at N or P. So I have NOP. And so then I find the angle across from it, which is QOR, are vertical angles. Okay, so that's one pair of vertical angles. When you have two intersecting lines, they always form two pairs of vertical angles. So the other pair would be if I looked at NOQ, which is this one here. Okay, and I'm just using 2 marks to indicate this angle. That would be vertical. If I go to across to it, would be this angle here, which is angle POR, okay, or ROP. So whenever you have two intersecting lines, they always form vertical angles, two pairs of them. And the vertical angles are the ones that are directly across from each other. So we're gonna look at the packet. This is actually page 16 because I've updated the packet this semester. So in the figures below, we're going to identify at least one of each of the following: a straight angle, a right angle, an acute angle, and obtuse angle. And then a pair of complementary angles, a pair of supplementary angles, and a pair of vertical angles. And we're going to use proper notation when we're naming the angles. Okay. So let's talk about like finding kind of some of these other measures. So this angle DBC is 49 degrees. Okay. So that therefore angle DBC is acute because the measure is between 0 and 90. And so we're talking about this angle here, DBC. Okay, again, I could name it CBD. So if we think about this other angle here, we know that angle ABC here, A is a straight angle because it forms that straight line and it would be 180 degrees. So if angle ABC is 180 and this part of the angle is 49 degrees, we can find the measure of angle ABD, this side, by doing 180 minus 49. And that would give me the measure of that other angle ABD. And so that angle ABD is going to be 131 degrees. So as a result, angle ABD is obtuse because it is more than 90 degrees, but less than 180. So if we go back to this one here, we're just going to start with kind of like obtuse, acute, and straight, and then we'll come back to the angle pairs. Okay, so we have this entire angle EFG, and we have this angle HFC, which they tell me HFG, sorry, which they tell me is 22, and this angle EFH. So they should have the box here, they don't, but we're going to assume that this box is here to indicate that this angle is 90. So therefore, angle EFG is a right angle. So we know that HFG is 22 degrees, okay? So it is less than 90. And so I'm just gonna more like write acute here and then obtuse because we're gonna have a few. So acute, we would say angle HFG. Okay, so HFG would be this 22 degrees. And then I'll just add the one we found before, angle DBC. And then this angle, I mean, you can calculate it. Some of you might be able to tell just by looking at it. This angle will have to be less than 90 because the whole angle is 90. I would subtract out this piece of the angle, which is 22, to give me the measure of angle EFH, which is 68 degrees. And so again, E, F, H are those three letters. That would also be an acute angle. So for obtuse, again, we have angle A, B, D. Now, if we look at our third diagram, we have this angle, which is 29, LMJ, okay, because that is less than 90 degrees and greater than 0, it is an acute angle, LMJ, again, using three letters. So then if we think about this next one, let me add straight. So we're going to talk about more straight angles. So this, we already know angle ABC, but we have this angle here, IMJ, and that is a straight line. So it is a straight angle. So angle IMJ is a straight angle, which means it adds up to 180 degrees. So if I know that this piece, LMJ, is 29, I can find the missing piece by doing 180 minus 29, because again, they add up to 180. So this would be 151, which makes that angle IML to be an obtuse. And then we can kind of see that we also have this straight line here. Okay, and remember this point is M. So we also have that straight angle, which would be 180 degrees, so KML. And then that would result in, we could find this angle because we have a straight angle. We know that IML is 151. So this is going to be 151 minus 29. Oops, sorry, 180 minus 151. Because we have a straight angle, which is 180, we're going to take out this angle, which is 151. And that's going to give me 29. It's going to be the same measure as that one. So that makes that an acute angle. So angle, again, three letters, IMK is acute. And then we have this last one, KMJ, which again, you can tell from the picture is going to be obtuse. But again, that's going to be 151 because you can either do the straight angle KML and do 180 minus 29 to get it, or the straight angle IMJ and subtract this 29. So those are all our acute, obtuse, straight angles for this. And then we have our angle pairs. So let me, I was trying to. Okay, duplicate the page. And then we're going to do on this page the angle pairs. So just give me a minute to erase all this. Okay, so then we're going to look at our angle pairs. So we have complementary. We have supplementary. And we have vertical. So for all of these, it's a pair. So we have to be naming two angles together. Okay, so again, complementary angles were two angles that shared a vertex that added up to 90. So we know that again, EFG is our 90-degree angle. So the two angles that make up that would be complementary. So it would be our angle EFH, which is this angle of 68. and angle HFG or GFH, which is this angle. So supplementary are two angles that add up to 180. So they have to form a straight angle. So we have a few of them. This first diagram, we have ABD and angle DBC form that straight angle of ABC. And then in this second diagram, we actually have a bunch. So we would have angle, if I start with this top angle, IML, and angle, if I'm doing this straight angle, the other one that makes it is LMJ. Okay, so then we could do this other straight angle of K. Well, let's go back to IML or IMJ. We could also do the bottom two angles that make it this other side. So I could say angle IMK and angle KMJ. And then we have the straight angle that I outlined in green. And again, we have two sides of it. So we could either say angle KMI, this one here, and IML, make that straight angle. Or we could do the bottom two below it, which would be angle KMJ and angle LMJ. So those would be all of my straight angles. And then our vertical angles are the ones, again, formed by intersecting lines. So it's just this third diagram, but they're across from each other. So it would be angle IML and angle, okay, so IML is here. Just erase everything and all. So IML is here. And then if I want across from it would be IMJ. So this angle and this angle are vertical. And then if I do the two smaller angles, it would be angle JMK and so that's this one here. The angle across from it, which is this one of LMJ. And so those are my two pairs of vertical angles. Okay, so again, when you're doing complementary, supplementary, and vertical, you have to have two angles because it's an angle pair. Okay, so if you have any questions about angles, just let me know.